Hi everybody. In this video we're going to talk about iteration and functionals with both base R and with purrr. So purrr is the package from the tidyverse that we're going to cover in this video. And this is a bit of a departure from the other material that you're learning at this time, but it is important for homeworks that are coming up that are going to ask you to do iteration and functionals to answer the question. So that's why we're covering it here and now. So what are we going to talk about? I want to give a bit of a background or push the importance of iteration in data science. It's something that we're going to come across a lot in the second data science course, if you take that course, and even a little bit here. And so I want to mention why it's important. Certainly it's important for a computer science course to learn about iteration, to learn about the language, but here specifically, why are we learning it in a data science course is what I'm going to cover just a little bit. And then we'll have a review of the basic control structures that you learned about in the first R homework or the second R homework, one of those early R homeworks. We'll go over it a bit more explicitly. And then we're going to talk about functionals. What is a functional? No, that's not a typo. I didn't mean functions. A functional is something special, and so we'll talk about that. And then we'll talk about the purrr equivalents to those base R functionals, which are a function called map and friends. Okay, and then I'll talk about some others that might be useful. So why is iteration for data science important? Well, as I said before, in the modeling part of the course sequence, which is the second part, but really for any part, it's important to create concise and readable code. People often call this the dry principle or the do not repeat yourself principle. And so instead of writing, if I have to repeat a task 20 times on different parts of a data set, I probably shouldn't copy and paste 20 lines and change what I need to. I should really use iteration to help me. Okay, and so iteration is a tool for reducing duplication when you need to do the same thing to multiple inputs. Now there's two types of iteration or two types of programming that will help you do iteration. The first is called imperative programming, and that's the loops that you may be familiar with. And also there's another type, another way to think about iteration, and that's functional programming. R is a functional programming language, or a language that supports it more than others, and people use it more than others in R, and so we'll focus on functional programming here, but I also go over the loops, so we'll talk about imperative as well. Okay, so, and as I said, it's a functional programming language. Now, if you've had a significant amount of programming experience before, if you are a computer science major, or you've done a lot of CS courses, or used programming outside of your learning, formal learning. Anyway, if you have a lot of experience, this may be weird for you. You may want to feel like you should do a for loop, but if I ask you to do a functional, please do the functional. Okay, so anyway, basic looping. So imperative programming. I want to square every element of a numeric vector. Okay, so I have a vector 1, 2, 3, 4 here, and I want to square it. Now, R is vectorized, or certain operations are vectorized, and so I can do something simple like vec squared, and it's going to square every element in the vector. It's not going to do some weird vector calculus or something, right? It's going to do it element-wise, which is what we would want. Okay, but what if R wasn't so awesome? So we could use a for loop. And so a for loop in R, as you've seen before, looks like this: for variable in vector. And so the variable can be anything, and the vector can be also any vector, and it will iterate along the vector. So most people put 1 through something. If you want elements, if you're going by row or column in a data frame, so on and so forth, you want to use 1 to whatever, but you could iterate over any vector. I could iterate over A, B, C, D as a character, and if that would make sense in what I'm doing, it might work. So anyway, it's the for loop, as many things in R you'll find, is loosely defined compared to other programming languages. So if you're used to C++ or Java or something like that, the for loop is going to be a little bit different, as you've probably already seen. It's a little less strict. Okay, and so here would be the code, although it's a little verbose. I make a vector using the vector function, and I specify everything, and then I use some code down here. My variable I'm going to choose is I, so I in, and then I use a function called seq or seek along. And what seek along does is you feed it the vector. So it could be, it would be fine for me to just put vec there. But if I had a vector that didn't have 1, 2, 3, 4, and I wanted to sequence a 1, 2, 3, 4, that seek along function takes in a vector, any vector, and will create its own vector of 1 to length of that vector. Okay, so anyway, seek along is a helper function that I'm using here to make sure everything works right, and then inside the for loop I square every element. Okay, and I make a new vector, and I populate each element of that new vector with the old vector squared of that element. Okay, so anyway, I think hopefully you can follow that. We don't need to take too long on this because, well, we want to learn functional programming, not the imperative stuff that you probably already know from a previous computer science course. So other control flows, for loops are great if you know how many iterations you're going to go, how long you're going to go. But what if you don't know that? That's a while loop. Okay, that's a while loop. It's not really iteration based, but what if you the direction of your code depends on a condition? That's an if-else loop. And so that looks like this. The while loop looks like that up above, and the if-else statement looks like that. If you're used, so these are common to a lot of programming languages, so you probably know the gist of those. Okay, so now let's get to functionals. So why would I learn a functional over a for loop? Because for loops are so basic and every programming language has them. Well, it's always good to learn something new, but in R, for loops have a bad rap. So if you talk to a lot of people, not really talk to a lot of people, but if you look online, you'll find people saying that you shouldn't use a for loop because it's bad. Why is it bad? Well, people say it's slow. Now, that is sort of true, but R is a slow language compared to C++ or Java. I wouldn't say it's slower than Python, but it is slower than Julia. There are many languages out there, and R is a slow one. And so it's not really that for loops are slow. Everything is sort of slow in R comparatively. Now, really, do we really care about speed in this class? And the answer is no. If my for loop runs in 2 milliseconds and I could get down to a half a millisecond in C++, am I really going to take the time to code things in C++? And the answer is no. Hopefully, because R is more expressive, and it would so it reads better and it takes less time to write in general. And so, anyway, that's a discussion for another time. Sorry for going down that hole. But why do we not like for loops? Well, some people say it's slow. There is a bit of overhead to run them. in the language, which makes them a little slow, but we'll not go down that rabbit hole again. Here in this, in another book written by the same author that the book for the class is, Hadley Wickham, which we've talked about a lot, says that the real downside of for loops is that they're very flexible. A loop conveys what you're iterating, but not what should be done with the result. Okay, so, and you can read more of the statement. We want to use functionals instead. So a functional is a function that takes in a function and outputs a vector. Okay, so think of a function in the math sense. You put something into it and you get something out. You can put many things in and you can possibly get many things out. But there are all kinds of math arguments about what should be there. A functional, in our sense, takes in a function and outputs a vector. Okay, so that's kind of weird. Regular functions take in an object and spit out an object or a vector. Take in a vector and they spit out a vector. A functional takes in a function. That's new. And so there's that. There's one more. So function in, vector out. Okay, there's one more level that we aren't going to talk about, and that's a function factory that puts in a function and it spits out a function, which is kind of odd. Okay, but anyway, we're at the functional level. There are many base R functions. So the ones that we're going to talk about are apply, lapply, sapply, but there's also vapply. And then R has things that you might use in a math class, like you can integrate a function. Just, usual numeric integration. And so what do you need? So you think that kind of makes sense about why it's a functional, because, well, you need a function to integrate. And so integrate has to take in like two things: the range of where you want to integrate to and from, and then, of course, the function that you need to integrate. Now, if you haven't taken a math course and that sounds scary, don't worry about it. We aren't going to integrate functions in this course. There's also an optim function, which does numerical optimization, which is a really powerful function. Again, we won't use it, but also, again, needs a function to do what it needs to do. So it's a natural functional. Okay, so let's learn about these functions quickly. Apply applies a function over a matrix or array margin. So if I have a matrix and I want to, sum the rows or sum the columns, I can do that. Okay, so here, apply takes in three things: the matrix that it's summing, or you can think of it as a data frame sometimes. So data frame, the second argument of the apply function is the margins of the array. And so 1 is column, so 1 is row, 2 is column, and then you have combinations of them that get actually kind of confusing. And so we won't go too far into that. And then the third argument is the function that you want to apply to the row or the column or both. And so here you go. And so you see 6, 15, 24, that's if you sum the rows. Okay, and so you can get the sums of the rows quickly with apply rather than writing a for loop that iterates over each row or something like that. Okay, so 2, that's column, and you can do both of them. That gets a little confusing. So that's apply. In general, we're gonna work with lapply and sapply a lot more, and so here is the lapply function, and you want to make sure to say lapply or list apply. I had a friend in graduate school who just refused to pronunciate anything correctly, and he called it lapply. And so please don't call it lapply. It is lapply or list apply. You put in a list and you get a list out. So list in, list out. Okay, and so A list, we've learned about a list, but it's a very general structure in R that everything sort of is under the hood. But a list is also a vector. We don't need to get into the semantics. And so if I have my vector here, so I had my vector, which was 1, 2, 3, 4, remember from previously in this video, and then I make my own function sort of in place. It's called an anonymous function, or sometimes also called a lambda. So I made an anonymous function here that doesn't exist outside of the lapply call. I didn't make a function f somewhere and call f. I sort of made it in place. And so it gave me, I run this function, and it gives me a list out. So list in, list out. Okay? And so people like functionals. So if you look at this and say, why would I use a functional over a for loop, is that it's more expressive in the sense that if you understand a functional, the first argument is the list that you are wanting to apply stuff to, and the second argument is what you want to apply to that list. So it's very clear that I want to square every element of the vector. Okay? So with a for loop, I'd have to look into the loop and try to understand what the heck's going on. Here, in the function call, one line, very clear what's going on. Okay. Now, we have sapply. That's a simplify apply. So sapply, list in, it tries to guess the output of what you want, which is kind of dangerous. So sapply is a little bit of a dangerous function. At least with lapply, you know it's a list out. And so if you don't know what's happening, so you sort of don't know what sapply is going to give you until it does, that's hard to prototype code. That's hard to use code with different inputs. So if you're trying to use sapply in some sort of setting where you have to use it a bunch of times, you're not quite sure what's going to come out of it. And that's hard for production. So anyway, sapply is a little risky, but it tries to simplify the output. And so instead of a list, I get a vector. In this case, I probably want a vector and not a list, because lists are a little harder to work with. And so here, sapply would be helpful. Okay. Here's another example. So I make this time it's with a tibble. So I'm showing you how sapply works on another type of data structure. So I make a tibble. Each of them, so it has 4 columns. Each of them are 10 numbers that come from a normal distribution with mean 0, standard deviation 1. But that's not really important. So I have 4 columns, and I want to find the mean of each column. And so I can run sapply on that data frame. So sapply df mean. Again, once you know the syntax, once you know what a functional is doing, it's very, very clear that you're finding the mean of the columns. Okay, it's always going to work over the columns and not the rows for a data frame. Okay, and so there I get the mean of each column. Okay, now on to purrr. So it's the tidyverse function, tidyverse package that provides functional programming tools for doing data analysis. Okay, there are lots of functions in purrr that do basically the same things that those base functionals do. There's also added functionality. So there are special things that you might want to do that purrr allows you to do that sort of don't exist natively in base R. Okay, now it is outside of what we're going to see, and so we aren't going to go over much of them. But again, here's the cheat sheet that I always give. Okay, we're going to focus on more of like the first column, the map to pmap, invoke map, those things on the left. But there are also important ones, or ones that can be helpful sometimes, over on the right side. Okay, if we want to take elements out of a list and do things there. So anyway, this is by no means going to be all encompassing video on purrr. So the basic ones are map. Okay, so map is equal to lapply, and so here I can make a small function that just squares elements. Okay, and I could run the function on 1:3, which is the vector 1, 2, 3. Okay, and so it does the same thing. Okay, and I show you a version where you can pipe in that element into, well, it would work for both lapply and map, but I do it with map. So map is like lapply, list in, list out. Okay. Now there are variants, map if and map at. So this is some of the variants that can be helpful. So if I have a list, 1A3, okay, so it's a mixed type list. So I have 2 numerics and 1 character. When you try to square a character, things aren't going to go well. So you can't square a character, it would throw an error. Okay, and so if I tried to feed f to every element of the list, okay, I'm going to get a non-numeric argument to binary operator. That's a common error that you'll see all the time. That means you've tried to do something with a character, basically. And so that's no good. And so I can do something like this. I take that same x, I feed it to map if now, and map if has an additional argument, which is the conditions. You can create something that'll check every element and see if it is that, and it'll only map if that condition is true. So here I'm using a special function called, it's a function, although I don't have the parentheses around it, is.numeric, checks to see if something is numeric, and says true if yes, false if no. And so I only want to square numerics, so that's helpful for a map if. Map at does by position. Okay, so there are map variants if you want to simplify your output. So what are the sapply ones? There's a map int, map double, map logical, map character. So if I'm doing things to characters, doubles, logicals, integers. Okay. Sorry. And then lastly, purrr has its own style of anonymous functions. Purrr has its own style of anonymous functions. Base R anonymous functions look like this. Okay. Now, to go back, there we go. So base R used to only have one type of anonymous function. That's the one on the left. But maybe 1 year ago, around when this video, so a year before this video was made, R went through a fairly big change. So when it changes, there are three numbers associated with R. So we're on R version 4.1.1 or something. We're farther than 4.1 or 1.1. But there are three numbers associated with R. Okay, small changes. So every few months they update R. R comes to a new version, and when there are only small updates, the third number changes. So we go from R 4.2.1 to R 4.2.2. Okay. When the second number changes, so R 4.1 to R 4.2, that's a fairly big change. And then when we change from 3 to 4, so we changed from R 3.7 to R 4.0. When the big number changes, then you have a lot of changes happening, some major changes to the language. So when that happened, and it happened fairly recently, say a year ago, they added they added the pipe operator, which we've seen me use before, and they've added this special anonymous function to the right. Okay, and so it is the problem that people had with the left one is that you have to write out the entire name function. It's a lot of characters. And so the right is a shorthand. Purrr has its own style. Okay, and it looks like this. It starts with a tilde, and then, I have .x squared. The dot is the important part. So dot x represents the element of the function, or the argument of the function x, and I want to square it. Okay, and so you get the same thing. Okay, but the one on the right is much less verbose. Okay, and so here's a little helper to tell you, give you a sort of rubric of how they work. So dot x creates a function x squared. Dot x plus dot y, tilde, and then dot x plus dot y creates a 2-argument function x plus y. And you'll see over on the left other things that will work. You can take away the x. Okay, you can use a dot dot 1, dot dot 2. There are lots of options. It's kind of confusing at first. Okay, but I will help you along. And if you have any questions, feel free to email me. So that's the end of iteration. And hopefully, I know it was a little long, video was a little long, but hopefully helpful.